Hello friends, today we're going to solve coin piles problem of CSES problem set. So the question goes like, we have two coin piles containing A and B coins. On each move, you can either remove one coin from left pill and two coins from right pill, or two coins from left pill and one coin from right pill. And our task is to efficiently find out if we can able to empty both the pills or not. So it's like, so we have two pills of coins. Let's imagine this is a pill and a coin pill, and this is B coin pill. And there are two conditions. We can either remove two coin here, and for whenever we remove two coins from a coin pill, we can remove only one coin pill from B coin pills, or we can remove one coin from a coin pill. For that we have to remove two coins from B coin pill. So these two are the conditions. So let us see the example. Okay, so two coin pill and one coin pill. Okay, so let's say this is a coin pill contains only two coins and B coin pill contains only one coin. Okay, so we already have a condition. If you want to remove two coins from a coin pill, we have to remove only one coin from B coin pill. So for that, so I remove these two coins, and so I remove here one coin. So total coins from pill A are from A pill are 0 and from B pill are 0, right? So for this we have to return S, because A and B pills are completely 0 coins. And like let me take another example. So 2 and 2 2 and 2. So okay, so this is A coin pill and these are B coin pills. So our condition, if we want to remove two coins from A coin pill, we have to remove only one coin from B coin pill. Or if we have to remove one coin from A coin pill, we have to remove only two coins from B coin pill. So let us follow the first condition. Like second condition, I have to remove this coin. So for this I have to remove the two coins from other pill. So the remaining coin pills of A are 1, but the remaining coin pills are B are 0. So for this we are not able to remove the other remaining coin from pill A. So this condition fails. uh, Let me check the other condition. So if we can remove two coins from pill A, we have to remove only one coin from pill B, right? So now if even A pill contain 0 coin pills, B pill contain one coin, so which we can't able to remove that coin, so we cannot achieve our result. So we have to return, or we have to print no for this type of questions. Okay, so let us see how we can able to solve this question. So for this question the input is like, we have to take the uh, integer t, so which is nothing but number of test cases, and then we have to read a and b integers, which tells the number of coins in a pill and b pill, right? And the constraints are like, t has to be less than or equal to 10 to the power of 5, so that means integer is enough for this. And also a comma b, which is also less than or equal to 10 to the power of 9, so it also says that integer data type is enough for storing these a comma b values, right? So Let us see the approach. So imagine this is a coin pills and this is a B coin pills. Okay. So if we read the first condition, we can observe that we can able if we remove two coins from a coin bill, we can only remove one coin from B coin bills. So we have to do this n number of times so that we get a result as 0. If we get a result as 0, we have to remove, we have to print S. Otherwise, we have to print no, right? So here we don't know how many times we have to perform these condition in order to get the result 0. Like 0 coins in pill A and 0 coins in pill B. So I imagined it as so we have to remove X number of 2 coins from pill A and Y number of 1 coins from pill B. So if its result is equal to 0, I have to print S. Otherwise, I have to print no. Just like the above condition, if we can remove X number of 1 coin pills from pill A and Y number of 2 coin pills from pill B, if this is equal to 0, okay, S condition. Otherwise, we have to print no. Now, let's give in these conditions to each of the pills. We get A is equal to 2x plus y1 and B equal to x plus 2y. So, if we are solving these two equations, we get like 2a minus b equal to 3x, because we have to multiply with equation 1. Imagine this is an equation 1 with 2 in order to solving these two equations. So 2a is equal to 4x plus 2y and b minus x plus 2y. So if we subtract these two equations, we get 2a minus b equal to 4x minus x, which is equal to 3x, and 2x here minus 2y, which is equal to 0. Actually it is plus, but according to the mathematics, when we are subtracting two equations by elimination method, we have to uh, alternate the plus and minus symbols of equation 2, so which gives us 0 there. So that's why I'm not writing. So what we have to know, we have to know x and y. So because those two are the number of times we have to remove the coin pills from A and B, so which gives us 2a minus b divided by 3 equal to x. So if we are changing those equation positions, we get 2b minus a 2b minus a equal to 3y, right? So that means 2b minus a divided by 3 equal to y number of times. So these two are the resultant equations which we have to use in order to find whether we can able to make the zero number of coins in both the pills. Understand? So uh, other than this, uh, like if you observe the question for input 2 and 1, so for input 2 and 1, let us check this equation. So a is equal to 2 and b is equal to 1, so the result is like 2 into 4, 4 minus 2, so 4 minus 2 is equal to 2 divided by 3. So here we are not able to get the integer value, so what we have to do, so if we do this division, we must get like 0. 6 like that. So we are not actually, we will get the float value if we perform the division here. So to avoid this condition, we have to make sure the value of 2a minus b has to be greater than or equal to 0. If it is equal to 0, we already know that 0 by any number is equal to 0, right? If it is not equal to greater than 0, then we should return no as an answer. So like 2 into 2 minus 1, like 2 1, right? 2 1, right? So to do 4, here we get what? 4 minus 1, only 1, right? So which is actually equal to 3. So 3 by 3 actually it performs the division, right? So for second condition, we have to check first 2b minus a has to be greater than or equal to 0. So that means 2 into 1 equal to 2 minus a actually equal to 3, which is less than 0. So that's why for the input 2 and 1, the result has to be 0. That means no as an answer. No, 2 1. I'm sorry. For 2 1, we have to return S as an answer because we already have the inbuilt condition, right? So if you remove the 2 coins from A and one coin, we can only remove 1 coin from B. So if you perform the each step in one operation, so the result has to be 0. So that's why we have to return S. So like for this condition, so let's clearly understand this. Okay, so we have along with this condition, we have to check whether 2a minus b is greater than or equal to 0 or not. So here we have to perform the division, right? So we don't need actually, so if the division is performed well and good, so that means the resultant, the remainder has to be 0. So then we say, yeah, 2a minus b is actually a multiple of 3. If it is not, we have to return no. And just like the above, uh, we have to follow this second condition also. So equal to 0 and a minus, I mean 2b minus a is greater than or equal to 0, right? So now our input is 2 and 1 and 2 and 2. So for 2 and 1, so 2 is 4. 4 minus 1, so it is a divisible of 3, right? And so for second condition, 2a minus b greater than or equal to 0, so we have to check. So 4 minus 1, which is 3, which is greater than 0, so the first condition is satisfied. And for second condition, 2b minus a, right? 2 minus 2, so like 1 into 2 is actually 2 minus and b, here a value is 2, so that means here resultant is 0. So when 0 is divided by 3, we get 0 as an answer. So okay, now 2b minus 2 into b value is 1, so minus 2 equal to 0, so which doesn't which does satisfy our condition, right? So for input 2 into 1, yes, we can able to make the coin pills of a and b are 0. So for 2 and 2, so here 4 and 2, 4 minus 2 is actually equal to 2. When 2 divided by 3, we can't able to get the result 0. So here the first condition is fails, so that's why we directly return no as an answer. So this is about the behind intuition behind the problem coin pills of CSS problem set. So let us see the code. I use C++ code chef compiler. So see here, I'm reading the test case, number of test cases. So for each test case, I have to read the A and B values, right? So and then I'm actually checking my four conditions here. If they are satisfied, I have to return yes. Otherwise, I have to return no, right? See here, I'm actually checking. So 2a minus b is actually multiple of 3, and 2a minus b is actually greater than or equal to 0. And then these two are the opposite conditions of these first two conditions, right? Like 2b minus a is actually a multiple of 3, and 2b minus a is actually a greater than or equal to 0. So the same code is actually present in my VS Code editor. You can check it, right? So then let us see the result. Choose file and coin pills problem and then submit. So see, our code is accepted. Thank you guys.